Welcome again to Wickerson Studios. My name is Michael Wickerson. I am continuing with these GH Python node basics, and although I did a little short video on array of points that was kind of premature, I was just playing with number sliders in preparation for it. And what I've done here is put in a very simple script right here at GH Python script dealing with array of points. And what I brought in is an input, an integer, type int integer x, and type int integer y, and I'll be using those two variables, and then I'll have an output of point A out and point B out. The script is fairly simple. I'm still playing around with using Rhino geometry as RG and Rhino script syntax as RS. I've generated two empty lists of points A and point B, and I've done an iteration from I to range X, which I can play with and change. And you can see I can change the geometry, basically building a little weird structured railing construct in Rhino CAD, but doing it through the Python node. And it's really, I'm not going to ever make it. I just wanted to show the possibilities of this. And then I also brought in there's my X, and my Y is otherwise. And because I'm dealing with the variables I and J in here, I've inputted them as IIJ and I00 through two iterations of appending points to create lists. And you can play with that all you want. I mean, you can see how the form changes. I can't type J in here because it's not defined yet, but if I type that in, it's obviously going to transform the geometry and do something strange in a way that I don't actually want it. But you end up understanding the maths, understanding the actual. I have to run that one again. Yeah, that's the Y. Maybe I should slide it down here so you're looking at the X here, but I was just trying to clear my wires up. And then there's a lot of post old Grasshopper stuff happening afterwards. So once you get the script up and running, that's the main point, is how can you use the Python node as a kind of micro plugin that you like, that you can go deeper into the maths and change the input values and optimize it to what you like to look at. I think this is a cool little unit and very simple geometries, and these scripts will be on Patreon GH files for those that want them. Otherwise, you can kind of cut and paste them here. But I would really recommend for individuals in the Facebook private group GH Python, you just take the basic scripts. They're coming from simple knowledge out of the textbook, accommodating them or altering them slightly within here, playing within the Python node. But then afterwards, I've got 2 points out. So why don't I find the distance between them? So I have a list of data. And once you have numbers driving things, then I just have my 2 points, and I decided, well, let's build a line between this point and this point moved. I cleaned my tree because there was 7 items here, 19 items here, and then after I clean it, I think it goes, jumped up to 20. I've got a interpolated curve between them, which is kind of just structurally thinking of a railing. You've got to basically model with this, and of course I can change the scale, but in changing the scale there, I have that playing into the X factor as well to thicken the backboard, which is basically a simple little surface from points with a U count that matches the original X. So it keeps working every time I do it. And you can do some multiplication factors there. If you played around with Grasshopper and you've gotten kind of, into scripting things and you feel like Grasshopper is kind of like playing crossword puzzles, start to optimize it, start to think of modeling with it. And that's really what this series is about. It's for the sculptor to have basic Python scripts that you can jump back into, and I don't even know what would happen. I'm sure it would explode if I put in an exponent there. Multiply it by 2, you start building the structure up, and you have a really cool form as well. So I'm going to jump in there and show how I can think about making pieces this way, and this weird pipe does this funk down here because it's trying to understand a bunch of data. At any point, you can kind of take these and bake them in parts. So you have, like, that piece is obviously fabricatable. The rest of it can be moved aside and, whatever, pivoted and changed according to that. Okay, how would you make those pieces? And then when you come back in, you might want to just grab a little bit of, okay, let's bring the iterations down and make a much smaller piece, or make a very, I think they're kind of nice, small and simple when you keep the numbers fairly small. So let's just go 3 by 3. You get this nice little unit here that is makeable, and I'm thinking that number there is could use a factor, and you can go in and do the maths, and these are things you slowly become accustomed to. Pull that factor in here, let's slide it into there, and let's just have a little multiplier. So I do a lot of post node in the Python, except I just put on, let's do a little multiplier integer in here as we take that up, and we can thicken that outside. You can see I'm stretching it in the X direction, so it's making this kind of 45-degree angle on that plate. You can change your vectors and play in different ways, but otherwise I'm sitting here modeling with a very simple Python script, what happens if I go back down to what it was, or what happens if I multiply by the I iteration. I'm sure it'll have another effect, and there you go. You're building some pretty cool geometries. And that's really what it's about, getting a handle of it, thinking of it differently, scripting as much as you can, learning these simple functions, add point, append, point 3D if you're going to work in Rhino geometry. Not too many funky things happening here. Obviously, range is a built-in function for what you're doing, and that's simply what I'm up to. And I like these forms as I build them. Now I have this clean tree, which is 111, but obviously, if you didn't like that cap unit, you could go in and do a quick quote 2 and throw on the caps and make them nice and rounded. That might change your geometry and make it a little smoother. So you still have that ability. It's for kind of people who've done a little basic Grasshopper and now they want to play around with the possibilities of very generic, simple, this is an array of points code, and now we're going to put in some conditionals that give us some control. So I think what you're doing to your algorithms is kind of optimizing them, and you're generating them differently, and you're thinking of computation, but really what you're doing is using the Python node to drive data. And for me, as soon as I get into a series of numbers, I start thinking like what I've learned in Revit a little bit about Dynamo and how numbers drive most optimization formulas in input and output. So I like that. It's pretty cool to me. It comes back to your initial variables. As you change it, you can kind of explode things out, kind of nonsense-wise. And then in the end, if you wanted to actually take that to fabrication or send it to engineering or start to become an engineer in yourself, bust apart into pieces, you still got this ability to make every unit, and you can still do a lot of CAD with that, change, warp, position, and model like you used to do in CAD. Anyhow, so 6 minutes, 7 minutes. Hope you enjoy it. I'm going to continue. That was Array of Points Part 2, and we will jump into conditional examples after this.